Measurements in fiber optic installations. Ultimode OTDR. This is a demonstration of the Ultimode OR20 reflectometer's capabilities, presented during optical fiber line measurements. Before measurement, it is necessary to clean the breakout box port and the launch fiber connector that will be connected to it. Ultimode launch fiber shown in the video is terminated with a blue SC UPC connector on one end. This is inserted into the breakout box port, while the other end is a green SC APC connector, which is connected to the reflectometer. This device eliminates the so-called dead zone of the reflectometer at the beginning of the measurement section. This tester is a compact device with a touchscreen display. On the left side, besides the power switch, there is a USB-C port used for charging and downloading measurement reports to a computer. On the opposite side, switches for flashlight and visual fault locator can be found. At the top, there are sockets for the visual fault locator and optical power meter. To the left of the flashlight, the reflectometer socket is located. It is also utilized by the built-in light source, used in transmission method measurements. Before measurement, it is mandatory to clean the reflectometer connector and the launch fiber connector inserted into it. Dirty connectors are the common cause of problems during measurements, generating significant back reflection at the beginning of the measured path, making it difficult for the reflectometer to interpret the data obtained from the further part of the fiber. After turning on the device, proceed to the OTDR menu. In the Setting tab, changes to measurement parameters can be made. The WL slider allows setting the wavelength of the generated signal. In this case, 1310 nanometers option was selected. Time parameter sets the measurement duration, also known as averaging time. This is the period during which the reflectometer collects measurement data and averages their values. If large number of measurements is necessary, try lower values. However, this may negatively affect the noise on the resulting graph. Mode slider sets the measurement mode. Auto is a mode with averaged values, where the reflectometer automatically adjusts the values of the next two sliders, namely pulse, responsible for the width of the generated pulse, and range, which stands for measurement range. If RT option is set, unaveraged measurement values are presented on the screen in real time. The AVG option is a mode with averaged values where pulse and range are set by the user. In this case, this option was chosen. The line, including the launch fiber, is 1,650 meters long, so a measurement range of 2.5 kilometers was selected. Setting range value affects the available options for pulse width. This parameter is responsible for the reflectometer's dynamics. The longer the pulse, the greater the power of the signal launched into the fiber. It allows for measuring longer lines with more events, such as splices or connectors. Setting the values to high generates large dead zones and increases reflections from events. Optimal values should be selected for each situation. In this case, 25 nanoseconds were set. The Measure button initiates the measurement, which, according to the settings, lasts for 30 seconds. During this time, the reflectometer collects data from the measured section and averages them on a chart, called a reflectogram, displayed at the top. After completing the measurement, events in the optical path are marked and numbered on the reflectogram. The list of events is also displayed in tabular form. The plus button opens access to additional options. Markers that are not needed now are hidden, and a summary of the entire measurement is displayed in a concise form. The summary includes line length, 1.65 kilometers, total line attenuation, 1.562 decibels, and parameters used in the measurement, wavelength, pulse width, and measurement range. Now it's time to analyze the reflectogram. Event number 1 is the beginning of the measured route. This is the connection of the reflectometer connector to the launch fiber connector. Second event is the connector marking the end of the launch fiber and the beginning of the optical path we want to measure. In other words, it is a connector in the first breakout box. Measured segments of the optical fiber are always presented between the events. The next connector, event number 3, is 153 meters away from the switch connector. After a long cable section, over 1 kilometer long, event number 4 is visible, which is the connector of another breakout box. After another 156 meters of cable, event number 5 is visible, the last connector, after which 163 meters of fiber optic cable are installed. The last event is the so-called end of the line. In this specific case, it is a connector in the last fiber optic distribution box, but the parameters of the event marking the end of the line are never measured. Further on the reflectogram, there is only noise. The described events and their parameters are displayed in the event table below the reflectogram. The columns of the table show event number, distance of the event from the reflectometer or lengths of fiber segments, insertion loss of the event reflectance, attenuation coefficient of fiber segments, total attenuation of all events. Analyzing event number 4, which is an SCPC type connector, it can be seen that it is 1,330 meters away from the reflectometer. Its loss is 0.061 decibels and the reflectance is 57 decibels. This is a complete information set for this specific connection. This event is preceded by a fiber segment measuring 1,017 meters, and after it, a fiber segment measuring 156 meters is installed. Measurements are saved in the device's memory by pressing the Save button, followed by typing in the file name. Information about the wavelength and pulse width of the measurement is automatically added to the file name. This data can be later used in external, free software for generating measurement reports. Ultimode OR20 can be used for quick testing and connection analysis, thanks to the IOLA, Intelligent Optical Line Analysis function. Here, a measurement of a typical subscriber socket attenuation was performed. Ultimode launch fiber with SC-APC connectors on both ends was used for the measurement. All connectors were cleaned beforehand. After turning on the reflectometer, IOLA mode was selected. There is an option here that allows for measuring 2 wavelengths simultaneously by moving the slider to both position in the settings. This allows to directly compare the results of both measurements and drawing appropriate conclusions. The remaining parameters in both options tabs are left unchanged. Start button initiates the measurement. When using both wavelengths, the procedure always takes slightly over a minute. After completing the measurement, 3 sections are visible on the reflectometer screen. Graphical representation of the measured line with events occurring in it, event table, summary of the entire measurement along with information about whether the line is done correctly. In this case, fail message suggests that there is a problem in the installation. This is also evident in the section with the graphical representation of the tested line. The problematic event, in this case, the connector indicating the subscriber socket, is marked in red. Event 2 is the end of the launch fiber and the beginning of the measured line, a connector in the socket. It is located 159 meters away from the reflectometer because that is the length of the launch fiber. Information from the event table shows that the cable from the socket to the end of the line is just over 49 meters. The measured attenuation at the socket was 2.185 decibels for a wavelength of 1,310 nanometers and 5.196 decibels for a wavelength of 1,550 nanometers. The reflectance values also differ significantly. Measured attenuation is significantly too high, and additionally, much higher for a wavelength of 1,550 nanometers. Presented data suggest the occurrence of a macro bend in the fiber. At first glance, everything inside the subscriber socket seems to look normal. To locate the bend, another function of the device was used, the Visual Fault Locator, VFL. The breakout fiber was connected to the VFL port. The side button of the device activates the visible light. Immediately, the place that may cause higher attenuation in the socket is visible. VFL can also operate in pulse mode, which is useful in situations where constant glowing light localization is difficult. In summary, the reflectometer has two operating modes. The first, Otdr, is intended for advanced users who can read reflectograms. It provides more information and allows manual control of measurement parameters. The Iola mode, intended for beginners, speeds up fault detection in the network. Thank you for your attention, and we invite you to our online store, dpolnet.com.